Welcome to the deep dive. Today, we're getting into a specific problem from linear algebra, something a listener actually shared with us.
Yeah, it's a solutions document. Looks like it's by Sun-Con Chang for Homework Quiz 1.2, Problem 5 specifically.
That's the one.
And it deals with a system of linear equations. It's quite good because it doesn't just, give the answer. It shows the whole process.
Exactly. So, our mission for this deep dive is really to unpack how Chang finds this parametric solution. It's, what, 3 equations, 5 variables?
That's right. 3 equations, 5 unknowns.
And then we need to dig into the logic behind the 2 proofs he gives, one showing the solution's actually correct.
And the other showing it's the only set of solutions that it captures everything. It's about completeness.
Right, understanding that structure. Okay, so let's look at the system itself. What are the equations we're starting with?
Okay, so the first one is by 1 minus by 2 minus 2 by 3 plus by 4 minus by 5 equals 2.
Got it.
Second one, by 3 minus 2 by 4 plus 3 by 5 equals 1.
Okay.
And the third, by 4 minus 5 by 5 equals 1.
3 equations, 5 variables. The source mentions the system's already in a kind of helpful form. How does it identify the key variables?
Well, it looks at the structure. You see how by 1 is the first variable in the first equation.
Yeah.
And by 3 is the first new variable in the second equation, and by 4 in the third. Chan calls these the leading variables. They sort of lead each equation.
Okay. By 1, by 3, by 4 are leading, which leaves by 2 and by 5.
Right. Those are the independent variables or free variables.
And the source sets them as parameters, like by 2 becomes as, by 5 becomes t. Why is that the move?
That's really the core idea for these kinds of systems. Because they're independent, you can essentially choose their values. Any s and t you pick will lead to a valid solution.
So setting them as s and 2 lets us write a general formula for all the solutions.
Precisely. It defines the entire solution space in terms of those parameters.
Okay, I get it. And the method shown is back substitution. So you start at the end.
Yeah, you start with the last equation, the simplest one usually. Here it's by 4 minus 5 by 5 equals 1. Since by 5 is our parameter t, we can solve for by 4 directly.
Right. The source shows by 4 minus 1 plus 5. Easy enough. Now we know by 4 in terms of t, and by 5 is t, we move up to equation 2.
Exactly. That's by 3 minus 2 by 4 plus 3 by 5 equals 1. Now you just plug in what you know.
So substitute the 1 plus 5t for by 4 and t for by 5.
Right. And then you just do the algebra to solve for by 3. Chang's solution gets by 3 equals 7t plus 3.
Okay, building it up piece by piece. We have by 3 and by 4 in terms of t, and by 2 is by 5 is t. So final step, the first equation.
The big one. By 1 minus by 2 minus 2 by 3 plus by 4 minus by 5 equals 2.
So substitute everything in L, 5 by 2, that's 70t plus 3 for by 3, the 1 plus 5t for by 4, and t for by 5.
Yep. Bit more algebra there to isolate by 1, but it works out. The source shows by 1 equals s plus 10t plus 7.
And bam, that's the whole parametric solution set from the source. By 1 equals s plus 10t plus 7 by 2 by 3 by 4 by 4 plus 5t, and by 5 by 5 by 5t. And this single form, it covers every possible solution.
That's the claim. Infinite solutions, all described by picking values for s and t. But finding it is just part 1, really.
Right, because Chang's document then proves it. First, that this formula actually works. How's that done?
Oh, that's the satisfying part. You just plug the parametric formulas for by 1 through by 5 back into the original 3 equations.
Just check the algebra.
Pretty much. You substitute them into the left side of each equation. If you simplify it all down, you should get exactly 2, 1, and 1, the original right-hand sides. The source walks through it, confirms it works.
Okay, so we know it's a correct solution form, but how do we know it's the only one? That we haven't missed some other weird solution that doesn't fit this S and T pattern?
That's the second proof, proving uniqueness, or maybe better put, completeness. It's quite clever.
How does it work?
The source says, okay, let's imagine there is some solution out there, any solution. Let's call its values U1, U2, U3, U4, U5.
Just some arbitrary set of numbers that satisfies the original equations.
Exactly. If U1 through U5 do satisfy those equations, then they must obey the same relationships we found through back substitution.
Meaning,
if you plug U1 through U5 into the original equations, the third equation forces U4 to be equal to 1 plus 5 times U5.
the same pattern as our parameter t.
Precisely. And the second equation forces U3 to be 7 times U5 plus 3. And the first forces U1 to be U2 plus 10 times U5 plus 7.
So Any solution must look like our parametric solution. You just set u2 equal to s and u5 equal to t. It has to fit the mold.
Exactly. It shows that our parametric form isn't just one way to write solutions. It describes the entire set of solutions. Any valid solution fits that structure.
That really ties it together nicely. So this deep dive into Chang's document, it really laid out the whole path, identifying those leading and independent variables.
Using the structure.
Then using back substitution to build up the general parametric solution.
Step by step.
And finally, those two proofs. One, just verifying it works by plugging it back in.
The sanity check.
And the other, more abstract one, showing that any solution has to conform to that parametric form.
Yeah, the key takeaway really is that the source provides this complete methodology. It's not just, here's an answer. It's, here's the answer, here's why it's right, and here's why it's the only form of the answer.
And understanding that process, finding the solution and proving it's complete, that feels really fundamental. It's about the underlying structure.
Absolutely. It's more than just calculation. So maybe something for you to think about. What happens if you have a system where there are no independent variables, say 3 equations, 3 unknowns with a unique solution? How does this change? Or think geometrically. These equations are like hyperplanes in 5D space. What does this parametric solution with s and t tell you about how those planes are intersecting? That's kind of a mind bender to visualize.